This is a capacitive circuit. It only contains a single capacitor and AC sources. In this case, this is opposite to the resistance circuit connected to AC source. In this case, voltage and the current is opposite to the resistance circuit. In the resistance circuit, we have seen current and voltage are in phase, but in this case, they are out of phase. When the voltage across the capacitor is maximum, current is minimum, or vice versa. And from this figure, we also can see that this red one is a current curve, and this one is voltage. Blue one is the voltage, and we can see this current curve is leading by 90 degree, or 1/4 of a cycle. Okay. In purely capacitive AC circuit, the current leads the voltage by 90 degree, or 1/4, 1/4 of the cycle. So we can define the capacitive reactance. Reactance is similar to the resistance. In resistance, we define this resistance. Resistor, we define resistance. Similarly, in capacitor, this is the equivalent to the resistance, and we call it capacitance. Capacitance is inverse of angular frequency, multiple of angular frequency omega and the capacitance. Omega, this omega is 2 pi f, right? 2 pi into frequency. So C is the capacitance. As like the Ohm's law, we can define voltage. Root mean square voltage, which is denoted by VRMS, will be equal to root mean square current and reactance XC. So we know voltage V from Ohm's law. Voltage V equal to simply current into resistance, right? It's like that. So we can say our current is equivalent current, it's same thing, and X, that is reactance, is equivalent to resistance in Ohm's law. Let me erase it. Okay, let me clear everything and then we can move forward. Okay. So now inductive reactance. So what is the inductance? It is a coil connected in the circuit. So when a circuit is connected in AC circuit, a coil is connected in AC circuit, and if you change the current with time, there is a generation of EMF that we called self-inductance. That induced EMF, which is denoted by this E, is equal to negative of L and the time rate of change of current. This term is said to be time rate of change of current. That means current is changing with time. Time rate of change. Rate of change. Okay. Okay. So the constant term right here, L, is called inductance. The SI unit of inductance is Henry, and simply you can say yes. Let me clear everything. Okay. Then, so this is the circuit having inductance, which is pure inductive circuit. So in this circuit, just inductor is connected to source, and voltage and current are opposite in phase. As like the capacitor, they are opposite in phase. So inductive reactance is denoted by XL. As like capacitive reactance is denoted by XC. Inductive reactance is denoted by XL and given by product of angular frequency into inductance. This is inductance and this is angular frequency. So angular frequency is 2 pi f. So this is the formula to calculate inductive reactance. So if you have the value of inductance and angular frequency or frequency, simply frequency, then you will get inductive reactance. Okay. So same like the Ohm's law, we can write down voltage equation for inductive reactance. So voltage RMS, which is root mean square voltage, is equal to root mean product of root mean square current into inductance or inductive reactance. Okay. So impedance. If all the circuit, all the components are there, resistance, conductor, and inductance, then we can say RLC. R is the resistance, right? L is inductance and C is capacitance. If all three or any two are connected, you can say if there are R and C, we can say RC circuit because there is resistance and capacitance with AC source. If there is L and C, we can say LC circuit, RC circuit or RL circuit. Okay. So if all three are connected in a single circuit, we can say it is a RLC, LRC circuit or RLC circuit. Okay. In that case, in this case right here, in this circuit we have R and C, resistance and capacitor. So it has an impedance. Impedance means total resistance because of this resistance and capacitance. Capacitance has certain resistance and this resistance has also resistance, right? So it is denoted by Z and given by R square plus XC square, right? This is the impedance and this is resistance. Okay, this one is impedance. So from Ohm's law, we can again write down voltage, which is equal to root mean square current multiplied by impedance. This is like current. So this is a RL circuit. So in this case, impedance will be sum of what? Resistance and inductance, inductive reactance. Right? This is inductive reactance and this one is contribution from resistance. Okay. If all three components are present, resistance, inductor, inductance and capacitance, then overall impedance will be sum of all three and it is given by this one, R square plus XL minus XC square. And angle between the voltage and the current, we know they are not in phase when there is not pure circuit. The voltage and the current are in phase only if there is a pure resistive circuit. Pure resistive circuit means there is absence of L and C, right? Only R is connected to source. So in that case, when you have inductance or capacitance in the circuit or all, then there is a certain angle between voltage and the current that can be calculated by this one because the contribution of this angle is from capacitance and inductance, only terms related to these are the major factor, right? They are numerator. So XL minus XC divided by R. So we can calculate phase also. So here different components is given, and in this table with its impedance. So if there is only R, the impedance is R. If capacitance is there, XC is its impedance. L, XL. L means inductance, right? RC circuit, this is the impedance. RL circuit, impedance is this one. If there are all three components, L, R, C, then impedance is this much. Okay. The phase angle also gives the power in the circuit, and we know the average power is equal to product of root mean square current into root mean square voltage and angle between current and voltage, cos phi, cosine of angle between them. Okay, so if you express this one, you know uh, voltage VRMS is equal to I RMS root mean square current into Z, right? So if you insert this value, right here, you will get this expression, right? Because IRMS will get multiplied, which is I square RMS, IRMS square, then Z cos phi is here.